Hello? There we go. Professional streamers here. Pro streamer strats. Anyway, hello and welcome to United Astronomy Clubs of New Jersey. We're here on site on this oddly cold, snowy, rainy, very cloudy day. Fun facts, we got at least a covering of snow last night. So it is a little bit less than ideal up here at the observatory, which is why we are using the indoor lecture area this time. Normally we would be outside because it's just a lot nicer outside. But for anyone, well, I'm just going to give people a little bit of extra time to find parking, get in here, find some seats. Do want to point you towards our website, uacnj.org. It's where you're going to find a list of all our upcoming talks. You're going to find information about all our member clubs because we are a club made up of other clubs, and we do encourage people to actually join their local astronomy club because it's one of the easiest ways to get into astronomy and start learning. In addition, it'll give you all sorts of fun links, such as to our social media pages. We have a Facebook, we have Instagram, we have a Discord server. All great places to get in touch with us, ask questions, see anything that might be going on at the observatory as far as special events. And of course, as always, we live stream these, so we are also on YouTube and Twitch. We are currently live streaming this program. Hi, people online. If you haven't already, do hit those like and subscribe buttons. We do appreciate the support greatly. It lets us know we are doing a good job. So, since it seems, I think you guys were some of the last people to get parked. Now to go over the safety briefing. It is inescapable. Normally, after our presentation, we would have stargazing. Right now, there are not many stars to gaze at since it is cloudy. However, a few safety notes. When we are leaving, we are using our headlights because we do not want people run over. It is painful if you are the one getting run over. It is expensive if you are the person running people over. This is not Frogger. You do not get points for running people over. Let's avoid that. Also, if we are wandering around outside in the dark, do try and keep our flashlights pointed towards the ground so we are not blinding people. Nothing's worse than losing all the hard-won night vision. In addition, after the presentation, feel free to check out our little museum area and gift shop. I will be manning the gift shop after the presentation because still, as of yet, I am not allowed to be in two places at one time. As soon as you do, I can take over the world. But until then, I am very much contained. We are in Jenny Jump State Park. We do love our park people. If you are up here, you should, if you like camping, hiking, all sorts of that, you should check out the park website. They do have cabins and campsites available. And we do love our park people, so do support them as well. So, with that, you're not here to hear me rattle on for forever. You're here to see the presentation, which is, nope, that is not the presentation. That is a list of stuff. So, the presentation tonight is, nope, 5 conspiracy theories debunked by Paul Fischer. Yes, once again, Paul Fischer. Last week he talked because, unfortunately, our normal speaker that night had a personal emergency, so he's back for his own actual talk this time. Paul has a Bachelor in Engineering and Chemical Engineering from Stevens Institute of Technology and has worked in the environmental and chemical industries. Though always interested in celestial objects, Paul's official start in amateur astronomy was one night several years ago, lying in awkward positions on the roof of his on the roof in freezing cold, holding a pair of binoculars. He caught a brief, clear glimpse of the Galilean moons of Jupiter and was hooked. And after some introductory reading that puts my to be read pile to shame, he finally purchased his first telescope and is now an active member in the Northwest Jersey Amateur Astronomers and volunteers here frequently at United Astronomy Clubs of New Jersey, and yet still somehow finds time to frequently find himself outside at night in awkward positions, in the freezing cold, in the unbearable heat, battling the mosquitoes, seeing neat stuff in the night sky. And with that, here's Paul.
Hello everyone, and I'm hooked here. Hold on one second. There we go. And I hope you can hear me. It sounds like I'm on. And thank you, Kim. And tonight, yes, tonight is very similar to how it can be challenging weather-wise in the pastime of amateur astronomy. Some of the best viewing of things to view and some of the best skies might be during winter time, so a little colder and a little more challenging sometimes outside. But we're not really here to talk about that. Here, a little bit of, I wanted to go across some of the conspiracy theories that we sometimes hear up here. These might not be the most pernicious conspiracy theories out there, but some of the ones we hear up here, and I wanted to talk a little bit about them today. Why did I decide to do this? I'm not looking to get into an argument or start an argument with anyone. I'm not looking to win an argument that might happen. I wanted to elevate my own game, understand some of the facts and science behind why these conspiracy theories are not true. And I want to make sure that I stay humble, that I keep an open mind, and that I understand the science behind it. I don't want to presume that that I know more than other people on the subject. Remember, I'm an amateur astronomer. I am not an astronomer myself, so there's certainly many people who know a lot more about many of these subjects than I. So I wanted to make sure that I am in the right place mentally myself for these subjects. I wanted to give credit to these and to these two people. This is where I got my original idea for this presentation. Astro Alexandra. She does not debunk conspiracy theories as her main focus. She is a science communicator specifically for astronomy. However, she does occasionally clear up some misconceptions that people have about astronomy, so certainly a good resource to go to. And secondly, Sci-Man Dan, who is a little bit more, takes the gloves off and goes directly at conspiracy theories. The tone of his shorts is that he's really kind of disappointed that some people still believe some of these things. So he's a little bit more directly a debunker. But both good resources. The science is good behind both of them, and I recommend them. All right, what are the 5 bugaboos we're going to talk about tonight? We're going to talk about astrology. We're going to talk about whether the moon landing was a hoax or not. One that is maybe popular just because of some movies out there. What does an asteroid belt really look like? The Milky Way, is that, you see a picture of the Milky Way, that's got to be fake, right? Well, is it? Well, we'll explore that a little bit more. and then and I'm talking about images of the Milky Way in its entirety, and then finally the flat Earth. We're going to go into all of these tonight. All right, let's pick on astrology a little bit, or not pick on it, but maybe go into why astrology isn't a science. Certainly fun to read your horoscope and to and say, hey, that one was right that time. But does it have any scientific validity? All right, so let's start with a definition of astrology. Astrology uses a set of rules about the relative positions and movements of heavenly bodies to generate predictions and explanations for events on Earth and human personality traits. And that definition comes from Berkeley University, California, Museum of Paleontology, Understanding Science 101. And anyone who has ever looked in a newspaper and looked for your horoscope is familiar with the 12 signs of the zodiac associated with astrology. It's important to remember that astrology and astronomy kind of got their beginnings maybe from the same place. People had questions about how the things worked. They saw the stars in the sky. They showed up in the same place in the sky every year, and figured maybe that has something to do with it. Yeah, unfortunately, nope. What's happened is that astronomy started collecting data about such things and started making determinations about why these things showed up in the sky every year at the same time, what these things actually are, how far away they are from us, what are they made of, what type of influence they have on each other and on us. And the data started coming in and said, no, it's not really influencing us directly. So that's astronomy. Astrology's kind of stayed with the same, that these guys showing up every year is not a coincidence, and we're still going to assign meaning in our lives to this thing. So they diverged eventually as science developed and took off. So the question asked here is astrology a science? And these test questions proposed by the Berkeley University of California Museum of Paleontology, Understanding Science 101, is what you can use, according to them, what is a science. Does it focus on the natural world? Does it aim to explain the natural world? Does it use testable ideas? So you can't just propose an idea and then now it's fact, right? You have to test it. If you test it and it is confirmed, well, then you might be onto something. If you test it and it isn't confirmed, it's time to come up with another idea. Does it rely on evidence? Does it involve the scientific community? Do other people who study such things agree with you? Does it lead to ongoing research? Have you made predictions and then experimented against those predictions? And do the researchers behave scientifically or professionally, is another way of putting that. And for astrology, unfortunately, the answer for most of those is nope. It starts out really good. Does it focus on the natural world? There was observations made. There are these things showing up in the sky these asterisms and these other things in the sky that show up with regularity, and maybe they have some influence. So yeah, it focuses on the natural world. Does it aim to explain the natural world? Yeah, we're trying to find answers here. But then where it starts to fail and where it drops off is that it doesn't use testable ideas. It doesn't rely on evidence. It doesn't involve the scientific community or lead to ongoing research, and then researchers don't behave scientifically. What we know now through physics and chemistry in the modern world is that there are 4 forces to rule them all off, and I'm going to put an asterisk there that I'm going to ask you about. There's the strong force, the electromagnetic force, the weak force, and the gravitational force. And this the 4 forces to rule them all is a reference to Lord of the Rings because I'm a geek. But what is a possible but unconfirmed 5th force you may have heard of? Have you heard of dark matter and dark energy? Dark energy is a possible another force that we don't currently have an explanation or understanding of. That's why we call it dark energy, because something's making the entire universe expand, something and accelerate in its expansion. So something's making it go. It's giving it additional oomph to expand faster and faster. But we don't know what it is yet, so we're not going to necessarily call it one of the confirmed forces. So there aren't 5 forces, there are 4. But I want you to know that you've heard of dark energy before in some maybe science reports or science news reports, right? So note that scientists have told you about this thing, saying, hey, you know, this thing possibly exists and we're excited about it and we're doing research on it now. That is the difference between astrology and astronomy. Astronomy is a science because they are excited. They are involving the scientific community. It's leading to ongoing research, and researchers are behaving scientifically. We're letting you know we don't understand about this stuff. That's a professional consideration. So that's a big difference between astrology and astronomy. So let's talk about these 4 confirmed forces and this mysterious one, which we don't have any information on, could possibly in the future occupy a 5th line here. The strong force, the best theory is quantum chromodynamics. The mediators are gluons, and the range is 10 to the minus 18th meters. There'll be a test after the presentation on this stuff. You don't know. There's going to not be a test. You just have to know that these things are well defined. There's actual numbers, there's actual equations, and there's actual particles that mediate these forces identified and isolated by scientists. The electromagnetic force has the quantum electrodynamics is the best theory. The mediators are photons, and the range that they operate in is infinite. The weak force is weak theory. The mediators are W and Z bosons, and the range is 10 to the minus 18 meters. Gravitation, the 4th force, is general relativity. The mediators are the graviton, and that's in a different color because they actually haven't isolated the graviton yet. And the range in meters is infinite. Again, they let you know we haven't found this one yet. There's ongoing research, and they're upfront about not knowing that information yet. So if we take these 4 forces, would they apply to a 220-pound human? You know, a bigger person, 220 pounds. How much force would they feel from these four identified forces? This is really getting down to the meat of astrology versus astronomy. What could Jupiter be actually doing to me right now? How could I feel it? Well, the strong force is not applicable because we are not down within the nucleus of an atom, which is 10 to the minus 18th meter, right? The charge of Jupiter would be Coulomb's law. And I have a note here. Coulomb's law is 1 over 4 pi epsilon Q1 Q2 over R squared. All right, and it is thought basically that the planets are neutral charge to each other. So if you have no charge and no charge next to each other, what are they going to do to each other electromagnetically? Nothing. So that's why 0 newtons. I did see a graduate student propose a non-negative charge on the Earth because of some of the magnetic field of the Earth interacting with the sun. That interaction between the entirety of the Earth and the sun is less than the gravity of Jupiter force would have on you. Okay, so not a significant force, but maybe there's something actually there, but not a significant force at all for the entirety of the planet. So the gravity of Jupiter, according to Newton's law of gravity, which is not the best, but it is a good, maybe first blush at a quantity. Newton's law, which is not, again, not Einstein's theory of relativity, but you know, for some things this big might be okay. F equals, it's the again, the universal law of gravity. F equals G m1 m2 over r squared. And we can actually calculate, knowing a 220-pound human and the weight of Jupiter, or the mass of Jupiter, but divided by r squared, divided by the many millions of miles between us and Jupiter, and we can come up with a number, which is 0.12340 newtons, about a 0.404 newtons. And holding a piece of paper aloft on Earth. I pick up a piece of paper and just hold it like this. And you can see that's also near we'll round this to 0.04. So you can see that this one is 1,000 times smaller than this one. Jupiter's influence on a 220-pound human being would be 1,000 times less than holding a piece of paper like this. Barely there at all. And that's if you could isolate that 220-pound human from the rest of the planet. So does it really have an effect on you? Not really, right? So it's just not there. You're not feeling Jupiter at any point. All right, a parting shot at astrology. Axial precession is a thing. Ophiuchus is the 13th zodiac sign. So what's happening here is this is the north in the solar plane. This is our axial tilt, and that axial tilt. And that axial tilt is actually itself rotating around the axis of the solar system. All right. So this is we are pointing at the North Star currently, right? Our North Pole is pointing at the North Star. It's not going to be the same star forever. It's going to be pointing, it goes, points at different stars at a 22-degree angle, comes all the way around again, and then will point again at the North Star, like a top that is starting to lose its spin. And that, the period, how long it takes for it to go away from the North Star, go all the way around, and come back is 26,000 years. And what's important about that is that Ophiuchus is actually in the zodiac plane, and so there's actually really 13 zodiacs currently, and astrology hasn't recognized the 13th zodiac sign yet. So they're 13,000 years behind the times. So not so good. All right, so maybe astrology not a science. Still fun, still interesting to look at, but not a science. All right, let's take a look at the moon landing was a hoax. These two pictures are of particular concern for many people who think the moon landing was a hoax. They talk about why this flag seems to be waving on a body that does not have on the moon, which does not have an atmosphere. And they're concerned about why this planet, our planet, Earth, is seen on the horizon when the face of the moon is tidally locked. In other words, the same face is facing the Earth at all times, so the Earth theoretically should be straight up in the sky at all times. If you're standing on that face, you should be looking straight up at Earth, because we're always facing the same direction. However, there's two things here. One is the people who are worried about the waving of the flag here forgot about momentum. So once you ruffle the flag on the moon and there's no atmosphere, what's going to stop it from ruffling? Once you move it one time, what's going to stop it? Nothing. Nothing's going to stop it. There's nothing to stop it. It's going to move. It's just going to move until something stops it from moving. Newton's law of conservation of momentum. And here there's an even simpler explanation. You have to know no science for this. This picture was not taken from the surface of the moon. This was taken from the orbiter that's orbiting around the moon. So as it was coming up from the night side and saw the horizon, it saw Earth on the horizon as it was coming up over to where the face facing the Earth is. So this isn't really an indication of the true position one would see the Earth at if one was standing fully on the face that we see every night. The other two, I did here in the title mention a twofer. So in one photograph we get two conspiracy theories. Here's the other conspiracy theory. What is that? This picture indicating obviously that the Earth is what? Round. Nope, that's none of that's true. Here's the actual documented Apollo missions where we made it, all the Apollo missions actually. Apollo 1 ground simulations that ended in tragedy. First of all, people died here, professionals. So let's show them a little respect and not poo-poo something that shouldn't be poo-pooed. People in this a huge human endeavor, lost their lives trying to do it. Apollo 7 was the first Apollo mission to space. That's in 68. Apollo 8 orbited the moon, also in 68. Apollo 9, that's the first time they two modules were joined and went up into space. That was in 69. The first time they actually went to the moon was on the 10th. They didn't land there. The Apollo 10 brought the module to the moon. They orbited it and then came back. They did not land. Apollo 11, human feet on the moon in 69. Apollo 12, they did retrieve a surveyor. Did I indicate the surveyor in the previous? They left an instrument up there on the moon. They brought it back in Apollo 12, and they left a seismometer to measure, moonquakes. Apollo 13 is kind of famous. People may have seen the movie for it. Houston, we have a problem. Notable, the quote, failure is not an option, was only written for the movie. It was not an actual quote. So if anyone asks about failure is not an option, not an actual real-life quote, that's a movie quote. Apollo 14, Shepard went back in 1971. Apollo 15, the rover, the buggy, debuts. These are called the J missions. Apollo 16, also a spacewalk happened while they were doing it. And Apollo 17, which was also the last mission in 72. So Apollo 17 was the longest exploration. They stayed on the moon from December 7th through December 19th. All right. Here's, if that doesn't convince you that we have those data and dates and stuff like that, and many of us here, I still remember actually watching those on TV. I don't know if everyone here is old enough to remember that, but I watched them on TV. So who landed on the moon? The Soviet Union, 1959. The United States in 1966. It's not. We have an asterisk there because we were human beings setting foot on the moon, as opposed to other thing, robots or some sort of lander being on the moon. China in 2013, India in 2013, India in 2023, Japan in 2024. I just note that the Soviet Union and China are our nation's rivals, right? If they found anything that said, hey, the United States never made it there, they might have trumpeted that loudly and for everyone to hear, right? Yet that hasn't happened. Who has orbited or has satellites around the moon? So even more importantly, the 20th century, it was mostly the Soviet Union, us, the United States, and Japan had some in the 90s. However, in the 21st century, now that we're in the 2000s, many countries have completed successful missions to the moon. Many countries have eyes, have satellites around the moon, and can see what is going on the moon. Here is one such, or several such flybys, and you can find this on the NASA Scientific Visualization Studio. And here, lunar module, tracks, lunar module, tracks, lunar module. This is Apollo 11, Apollo 12, Apollo 14, Apollo 15, more tracks. Here's the seismometer we talked about. And here's another science module. Here's the rover left on there from Apollo 16. Here's the lunar module, more tracks, the dark lanes. And then here's the lunar module again, Apollo 17, surface electrical properties array, another science package. So orbiters that are there at the moon now have pictures. And notice that, look at how big this whole lunar module is in this picture. From an actual satellite that's orbiting the moon itself. This is not an Earth satellite, it's a moon satellite. See how tiny it is? See these tracks? See how tiny these instruments are in these pictures? This is from a modern satellite orbiting the moon itself. So people ask, why can't you see it from telescopes here on Earth? This is what you see when you look through satellites above the moon itself. We don't have any chance of seeing them from telescopes here on Earth. And we can go into the science a little bit, but it all has to do with the limitations of various frequencies of light and the resolution you can get from those calculations. It's just very difficult. The size of the telescope you would need to see such small detail on an object 250,000 miles away gets prohibitively and ridiculously large. Telescopes the size of the Earth, things like that. Ridiculous. That's why you can't do it from the Earth. I'm not 100% sure of the exact size of the telescope you would need to see a flag on the moon, but they start getting ridiculous quickly. All right, another reason why I believe that the moon landing was not a hoax is that Buzz Aldrin might knock you out. Famously, on September 9th, 2002, Buzz Aldrin, at that point 72 years old, punched Bart Sibrel in the jaw during a confrontation that Sibrel set up outside the Lux Hotel. Sibrel tried to press assault charges, but the court threw out the case, calling Sibrel the instigator. All right, so Buzz Aldrin's, being a pioneer and a rugged individual, a guy who rode an exploding vehicle into space to land on the moon, you might think that he feels a little strongly about it and has some strong opinions, and he surely he did. All right, another thing that might convince you is that we have all these documents. The design itself, the actual how everything was built, was put into the various vehicles, how they operated, all the training that went into it, all the data that went to supporting the training and the design and the documents. All that is public record. You can look at the thousands and thousands and thousands of documents and rebuild it and see whether it works. Now, you probably won't do it. None of us probably will. However, the feasibility of it, looking at those design documents, looking at how it was done, the history of it, you could probably tell that it was a real thing. The documents themselves, to create those thousands and thousands of documents, the cost to just do that is incredible, right? It would be a huge waste of time if it wasn't real. But you can look at them and check out the feasibility just from publicly available information. More of the design documents. And the other thing is, here in the United States especially, this was our thing, right? Let's take some pride and ownership into something amazing that we accomplished as a country. That's Buzz Aldrin, by the way. And of course, we're still taking measurements based on we dropped a laser reflector. Space lasers, that's cool enough already, right? But we are still doing measurements on the laser reflector that the Apollo missions dropped on the moon. That's why we're adjusting, like we know within a centimeter of where the moon is. We know it's going further away from us due to tidal forces, and the current measurement is around 238,855 miles. We're still taking those measurements to this day. All right, so maybe enough on the moon. The moon landing was not a hoax. Piloting skills and asteroid belts. Love this unnamed movie for legal reasons. Yeah, we'll give the credit to StarWars.com, but the movie is unnamed. Remember when that dude, the other dude, the princess, and the hairy dude, and the comic relief robots flying through the asteroid field? Do you remember that scene? That was a really cool scene, wasn't it? And it looks something like this, where all these asteroids are, they had to dodge the asteroids and fly around them and stuff like that. Nope, that's not what an asteroid belt is like. Our asteroid belt, the four largest asteroids are Ceres, Vesta, Pallas, and does anyone know how to pronounce that? I don't know how to pronounce that. Hygeia. The total mass of the asteroid belt is less than the mass of the moon. So all of the asteroids in the asteroid belt don't add up to our moon. All of them. The asteroid belt is between Mars and Jupiter. The orbit of the moon radius is 250,000 miles. Mars is something like 120 million miles. So it's bigger than that. Trojan asteroids precede and follow Jupiter in its orbit, and Neo's near-Earth objects intersect Earth's orbit. The asteroid belt is between 2.2 and 3.2 AU. That is 2.2 and 3.2 times the distance of the Earth to the Sun. That translates to 204 million miles, over 204 million miles, and almost 300 million miles. So the average distance of that mass spread over that amount of area in our solar system, the average distance between asteroids is 600,000 miles. So I think that's a lot less than 600,000 miles. So this concept of what an asteroid belt looks like, no good. So why does that perception exist? Why do people think that? It's because we get pictures like this, which is an accurate picture. Here's Jupiter, and then here's the inner planets, nice and small compared. However, see this is the asteroid belt. With the asteroids, I think these are actual plots of actual objects. See the purple dots there? In between each of those purple dots is 600,000 miles. You can't tell it's 600,000 miles by looking at this plot. Space is so big that it's difficult for our brains to conceive, which is why we need to rely on mathematics to get the facts. So these plots, look at that. Dot here, dot there. That doesn't look like 600,000 miles, and our brain's going to go, I don't believe it. You can't just eyeball it. You gotta do the math. So that's why the diagrams are deceiving, because our brains don't accept them. And so you gotta think about it a little bit. All right, the Milky Way is fake. The images I see of the Milky Way, it's fake, right? That can't possibly be true. If we were to change the claim a little bit, if the assertion is that we don't have a photograph of the Milky Way, then that would be correct. We would have to fly out of the galaxy, take a picture of the galaxy, and then fly back to our galaxy. We can't do that, right? That's likely, although we might visit stars some point in our species' future, it is unlikely that we will ever leave the galaxy. Unlikely. So, do we have a photograph of the Milky Way? We do not. So that would be true if that's how it was stated. However, we have pictures like this, where we're pretty sure we're a barred spiral galaxy, and that we have these arms, and we have these major features that look like this. We are pretty sure our galaxy looks like that. So how do we do that? Any guesses? That's not a photograph, right? We can make photorealistic maps nowadays using computer technology. And so artists know how these gas clouds, or artists and scientists collaborating know how these areas of gas and star clusters look in other galaxies. We know the position of all of these in a 3D environment because we've measured them. And so we can build photorealistic maps of our galaxy. It's not going to be perfect, but we're pretty sure it looks something like that. So what's an analog to that? Where have we done that type of thing before? This is a Mercator projection of our planet. It's Mercator Novia et, I'm going to butcher this, sorry, Auca Orbis Terrarii Descripto. Guess when this was put together? Yes, the 1500s. 1596. We didn't have a satellite in orbit around the Earth until 1957. Yet somehow this is quite obviously North America. This is quite obviously South America. It doesn't look exactly like that, right? But they got it pretty good. Without satellite, hundreds of years ago, way before we put a satellite up. And Africa and Europe and Asia is an even better likeness. So we can do maps without having the ability to take a photograph. And that's all that is. It's a good map of our current understanding of the Milky Way. And so this map here is made with real data and illustrative detail taken from similar galaxies. It's a useful aid to understand our galaxy. So no, the question is that not real? No, it's real. It's just a map, not a photograph. All right, the big one in my presentation anyway, flat Earth. The flat Earth's basic premise is that the Earth is flat. It has an edge, and I guess the atmosphere looks something like this, and the sun and the moon move around in the sky over the flat Earth. That, of course, is not true. We've known the Earth is sphere-like, spherish. An oblate spheroid is the terminology for a long, long time. Pythagoras proposed a spherical Earth. Aristotle did it agreed based on actual physical evidence in 384 to 322. Remember, if you're BCE, the 322 is actually closer to us in time. The numbers go down as they get closer to current times. Eratosthenes of Cyrene made measurements of the angle of shadows at the summer solstice in current Aswan and in Alexandria. And so he took a rod during noon and measured the shadow in one location, and took a rod in noon the same date in another location, was able to calculate the distance between those two places, and just from geometry, the angle those shadows made with the sun, was able to determine that the surface of the earth was curved, and had and calculated in a reasonable fashion the diameter of the earth. Interestingly, he employed oh boy, I should have looked up some of this pronunciations before the presentation. I apologize. The bematists measured walkers to determine the distance between the two cities. So in order to determine the distance between two far places, they had people then walked with and go 1, 2, 3, however long it took to go from one country to another back in ancient times. But this is the actual measurement, about 250,000 stadia. That's the steps. Or not, it's not necessarily the steps, but the measurement that they used back then. His results were being between 24,000 and 29,000 miles, agrees well with the modern measurement of 24,900 miles. And that's why his calculation of the size of the Earth was relatively accurate. So ancient times we knew, BCE we knew, and we calculated it. Christopher Columbus knew that the Earth was a sphere. He owned copies of books of the ancient Greeks, which discussed Eratosthenes and later attempts measuring the Earth's circumference. Most learned people at that point believed the Earth was a sphere, and for not only then in Columbus's time, but for most of history after Pythagoras. A modern resurgence of flat Earth thinking didn't come back until the 19th century, and the rise of some fundamentalism in the religious communities. All right, so not only do we have that history for most of enlightened modern history, that we knew it has been a sphere, we can some things that we ourselves can observe here. Here is the Humber Bridge in the UK. So this is the longest suspension bridge in the UK. It has these two towers, and of course the deck of the bridge is suspended from those towers, that being the suspension bridge. So it's a long bridge. Let's see, I have it here. It's in Yorkshire, England. It's 1.38 miles long, and the towers are 0.87 miles apart. What do you have to do when you build tall structures like that? It's pretty important that you get something correct. The vertical, the plumb, it's got to be plumb, right? It's got to be exactly vertical. Leaning one way or leaning the other, that much weight leaning one way or the other, and it's more likely, a lot more likely, going to fall. So it being plumb, exactly plumb, straight up and down, from the center of the Earth up, it has to be. However, interestingly, this tower and this tower are further apart on the top than the bottom. That's because they are not parallel as if the Earth was flat, but they are radial. So the center of the Earth is beneath both of them, and then they both point straight up. If they were around on the other side of the Earth from each other, they'd be pointing in opposite directions. But they're not. They're radial, so they're plumb, and they point along the radius from the center of the Earth straight up into the sky. Does that make sense? That's what plumb is. To account for the curvature of the Earth, the towers of the Humber Bridge are 36 millimeters further away at the top than they are at the bottom. So this distance is almost a mile long, and the difference in the difference in the measurement between the top and the bottom is only 36 millimeters. That tells you why you can't see by eye the curvature of the Earth. It's just so big that even being a mile apart, the difference is only 36 millimeters apart on these towers. 36 millimeters. You can't see it by eye. You have to measure it. And you have to measure it quite precisely, right? 36 millimeters. You have to know the difference, 36 millimeters over a mile. It's pretty precise measurement. You can't just eyeball it. It doesn't look flat. It doesn't look round to me. That doesn't make any sense. You can't do it that way. Here's even larger scale engineering, right? Large scale engineering. A bridge is pretty large scale engineering. Here is power lines going over Lake Pontchartrain. You can actually see the when the towers go in. What anyone who here does visual art? Any fine artists or took art classes? What's this point back down here? That's the vanishing point, right? But you can actually see the line curve as it goes off into the distance. But it takes that's way longer than a bridge. It takes a long way in order to actually see it. If it was just a perspective effect, what do we do with a vanishing point? We do straight lines to a point, right? But if it was just perspective, then the parts of the lines would line up in a straight line and they would meet at the vanishing point. But that's not what's happening. There's this actual curve that's happening. All right. So that's that thing. Let's talk about circles that are great. That's also IP that we won't mention. I don't know the meaning of the tiger there. So if you are on a globe and you want to get from point A to point B on the globe, the fastest way to do it is not in a Mercator projection straight line, but is along a line called a great circle. We know one great circle very well. We have a name for it. Can anyone guess what that is? The equator. That's a great circle. All a great circle is the equator drawn anywhere else on the globe. In any direction, anywhere else on the globe, that is a great circle. There's no real mystical meaning to it. It's just an equator that it isn't really the equator. It's drawn somewhere else. But here's what happens. This is what a great circle looks like on a map, and this is a straight line. So remember that the Mercator projections, you're trying to fit something that's a globe onto a flat piece of paper. And this gets really distorted up here in the northern regions, and as you get further away from the equator to the south, the same thing happens. And so these straight lines in between 2 points no longer look like straight lines because they've been distorted. So when someone says that the fact that airplanes and boats and anything they teach you in navigation travel along these great circles, they are traveling along the shortest distance between 2 points on a globe. They are not. You would have to travel to get a straight, the shortest distance between 2 points on anything flat would be a straight line, would have to travel in a much different fashion. But planes and boats that are traveling along the water here travel in these great circles. Money talks, other stuff walks. Forget about scholars, cartographers, military pilots, captain, and other enthusiasts who use great circles every day. Don't worry about those people. Just imagine that the airline industry alone was projected to spend over $600 billion on fuel in 2024. Imagine a flat earth proponent sitting down with the CFO of a major airline suggesting that she changes her airline's great circle routes to straight line routes because the earth is flat. Just think, sitting down in the CFO's office saying, that globe stuff is baloney, it's all flat earth, you should all be using this route and not this route. At $600 billion a year, their portion of it, I think the CFO might give that person their walking papers, right? They don't do it. The airlines use these great circles, and they don't do it because they are harboring some sort of conspiracy. They do these great circles because it affects their bottom line very, there's a big effect to their bottom line, and so they are following these great circles because it is saving them money. And that's the bottom line of that. It's just not, you can't argue with that. They're not going to change it. And finally, we have these wonderful photographs from space that show the curvature. Here's a very important photograph. Does anyone recognize this photograph? You might recognize the title. It's from a gentleman you might have heard of, Carl Sagan. It's in his book. As the Voyager was traveling out of our solar system, it turned back and took a picture of the Earth. This blue dot is the Earth. That round blue dot there is the Earth. Quite amazing. We have an object that we made traveling out of the solar system that can take a picture of our blue dot. Does that not hit you? Does that not speak to you at all? And here's Carl Sagan's own words. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. That's Carl Sagan, one of the greatest scientific communicators ever. And if that doesn't, why do you need anything else? You know, why create some of these conspiracies? Why do you need more than this? It's already magnificent and wonderful. Don't mess with it. Okay, everyone, that's my presentation. Urge you all to join an astronomy club. Stay safe, everyone, and enjoy your evening.
All right. Thank you for another great presentation, Paul. So we are going to be doing a question and answer session because I know online people had a couple of questions. So I figured you guys must also. Because I think a couple of you snuck in. No? You guys were already here. Okay. Normally people words. Normally people sneak in during the presentation. I just remind everyone, use their headlights. If you need the restroom, it is the porta potty outside. It's illuminated by red for ease of finding. So how question and answer is going to work is I'm going to hand you the mic so people online can hear the question. And online people, you just get to type and I ask your question. So I'm going to start out with the first online question, which was, when do you think we might put people back on the moon?
Yeah, that I don't think we lack any capability to do that. What we lack is the will, and I don't mean that some people don't really want it to happen. There's a lot of people who really do want it to happen, but it's politically it's about spending money, and what are we going to get out of it if we spend the money? And there's even competing priorities. Do we want to spend the money going to the moon? Do we want to spend money putting a satellite around the moon that launches us into the solar system? Do we want to spend the money going to Mars? So not only is there, politically is it a good idea, but there's also, hey, there's competing things that we can do with this money that are similar in nature. So it's
so
not an easy
to do, so little money and time to do it all.
It's not. Yeah, we can't do it all, and whether the political will exists to do it at all in the first place is a big question, and I think that's what's holding us back, not any capability of doing it.
And I think you had a question, sir.
I was just gonna add that Tony the Tiger used to advertise cereal, and he would say, "That's great."
Yes, he would, and that again, I was avoiding copyright liability. Just more of a joke. I don't think anyone really cares about my presentation here, so that was just, yes, that was Tony's analog. That was maybe Tim the Tiger there.
Yeah, when you were going over forces, I messaged Chris. I said, "It's me. I'm the fifth force when I'm hangry."
Yeah, that's true.
Let's see. Our next online question is, what are some other conspiracy theories that you know of that you didn't put into your presentation?
There are a lot of conspiracy theories. I don't look. I don't want to give my personal views on things because that's not what these presentations are about. That's not what we're about up here. And I don't want to anyone's ideology. I don't want to challenge that. I think having beliefs and etc. is important part of human experience. So let's not rain on anyone's parade. Let's accept it as it is, as they are. But let's also keep in mind that we put effort into these things, and this is knowledge that we have. Let's not have those things override our understanding of science the way it is. Nothing that I've heard up here is coming to mind of other I guess one of them that we get up here time to times is that we are currently being visited or have been visited by aliens. That's another one that we occasionally get. And no, I didn't address it on this one. But you can, Dan Kirby gives a good talk on the Fermi paradox and why we haven't encountered aliens yet. And so maybe tune in at when Dan gives that presentation, and he'll address the Fermi paradox and aliens at a later date.
Aliens. Right. Was there another question out here? Wow, we're quiet.
Okay.
I blame the weather.
The
everyone-
weather did put a damper on everything tonight. That's true.
Not gonna lie, after working
That's true.
after working outside for a bit today, I too kind of curled up in a blanket and took a nap with some hot chocolate. So perhaps, let's see, our next online question. And if online people, if you have any questions, do get them in, because I think this is the last one that I currently have in my portable internet box. Did Voyager take any pics of other planets as it was leaving the solar system, or was it just the pale blue dot picture?
Yeah, and now that I think of it, just don't look up for yourself what satellite actually out there. We had a bunch of missions to the outer planets, and that might not necessarily have been from Voyager. I may have misspoken on that one, but one of the missions, we flew out to Jupiter and Saturn and other places, so that could be from one of those missions.
There are so many missions.
There are many missions out that direction, but that was back in Carl Sagan's time. That picture existed. Right. I remember that, reading about it, and they had the ability to flip the satellite as it was leaving in order to get that, because you were headed out. Obviously, you weren't facing Earth, so they had to flip the satellite to take that picture. And so the question again being,
did it take picture? Did they
of other planets?
Like, bye guys.
I think now that if I remember, I think that's actually in the background of a bigger, that was actually in the background of a bigger picture. That might have been looking through the rings of Saturn or something like that. So yes, it got a bit of Saturn in there too. But of course, if you can imagine, the distance between asteroids, we said, was 600,000 miles. The distance between planets is millions and millions, tens of millions or hundreds of millions miles. So they might not be in the same frame all the time. So we might not get lots of the planets all at one time in one photograph.
It would have been absolutely awesome if they happened to be doing that.
If they all happened to be in a line on the when we were flying by, but that didn't happen, I don't think.
Like when they showed that one scene in one of the Lara Croft movies where, like, there's the big mechanical things and they zoom out and it's planets all aligning, and it's like, that would be neat.
That would be neat, and of course we wouldn't feel anything here on Earth if that happened, right? Because we know that's not how it works.
The planets are aligning soon. I gotta get my stuff in order. But no. Let's see. It looks like online questions. Last chance for questions out here. Are you just waving the traffic wand, or you have a question? Okay. Me neither. That's why half the time I'm up here dancing, because I'm incapable of staying still. But I want to thank you all for coming out here and joining us tonight for this presentation. Thank you all online who have tuned in. Like I said, do hit those like, follow, subscribe, whichever streaming service you happen to be. That is the sun, Paul.
Sorry. Let me... boy, what can I do? I can turn it off. lost our night vision. I don't think we have to deal with that.
Yeah, luckily it's clouded, so we're not really looking for much as far as the night sky. Just being wary of the animals like deer crossing the road, 'cause they tend to be running when it is. Oh, thank you.
Thank
Turned
you,
off
Chris.
the projector. I can see. I have eyeballs again. Anyhow, thank you all. Do follow us on our social media. Check out our website, uacnj.org. And with that, have a good night. Clear skies than we've been having,
Yeah.
and good seeing.
And thank you, everyone.